everybody, this is your host. Today we're going to learn about pressure builds diamonds. Okay, so this is an amazing experiment that shows how pressure can actually build diamonds. Now, for this experiment, we are going to use a special mixture that will allow us to visualize the process of diamond formation. The recipe for this mixture is given in the description below, but basically it consists of some simple ingredients that are mixed together and then melted down into a transparent liquid. Once the liquid cools down, we get these nice transparent crystals that look like tiny little diamonds. But the cool thing about these crystals is that they're actually pure silicon dioxide, which is the same composition as actual diamond. Now, to begin the experiment, we're going to weigh out all of the ingredients that we need. First up, we have 12 grams of sucrose, or table sugar. Next, we have 16 grams of sodium chloride, or salt. Then we add in 4 grams of citric acid. And lastly, we have 3 grams of potassium nitrate. All of these ingredients will react with each other to form a new compound called potassium silicate, which is the main component of our crystals. But more importantly, potassium silicate has the same chemical composition as diamonds, which is carbon. So at the end of this experiment, we should be able to grow some beautiful transparent crystals that are chemically the same as diamonds. Next, we're gone. Transfer all the ingredients into a beaker and then put the beaker on a hot plate. After adding a small amount of water to the mixture, we're going to heat it up while stirring it constantly until all of the ingredients have dissolved. This mixture isn't very stable though, so we have to keep heating it while stirring it to prevent the solution from solidifying. After a few minutes, the solution starts to boil, and at this point we have to turn the heat off and let the beaker cool down a bit. As the beaker starts to cool down, we see some white crystals start to form in the solution. These crystals aren't exactly what we're looking for yet, because they re not transparent and they re not diamond. But with a little bit more work, we can turn them into beautiful transparent crystals. To do that, we're going to pour the solution through a strainer to collect the crystals. The crystals are still a bit wet, so we're going to put them into an oven to dry them out. The temperature of the oven isn't really important here, but the most important thing is that the oven is turned on and that there is airflow over the crystals. This will help remove any remaining moisture from the crystals and make them nice and shiny. While the crystals are drying out in the oven, we can work on making a saturated solution. To do that, we're going to take a clean beaker and add about 100 ml of hot water to it. Then we're going to slowly add in some of the dried crystals into the beaker. We want to keep adding in more and more crystals until no more crystals can dissolve in the solution. At this point, we've made a saturated solution of potassium. Next, we take a clean test tube and add a few drops of the saturated solution to it. Place the test tube inside of a larger beaker and then fill the larger beaker with ice water. The reason why we're putting the test tube inside of an ice bath is to cool the solution down really quickly. This rapid cooling will cause the potassium silicate solution to supersaturate and become unstable. As it starts to crystallize, we'll see some needle-like crystals start to form in the test tube. It takes a few minutes for these crystals to form, but once they do, we can take them out of the test tube and see what they look like under a microscope. Under the microscope, we can see that these crystals are very long and thin. They kind of look like needles, which is why we call this process needle growth. Needle growth is a unique crystallization process where thin, long crystals form instead of the typical cubic-shaped crystals. Repeat this process a few more times just to make sure we get plenty of crystals. Now that we have a bunch of crystals, we can take them out and dry them. Once the crystals are dry, we can look at them under the microscope and see how beautiful they look. These crystals are so cool. They're absolutely transparent and they look like tiny little diamonds. But are they actually diamonds? Well, to find out, we can scrape some of the crystals onto a glass slide and then put a small drop of water on top of them. This will prevent the crystals from sticking to the slide. Then we can take a cover slip and place it over the sample. Lastly, we can place the slide on a hot stage and heat the crystals up to about 700 degrees Celsius. If the crystals melt, then they must be made of pure carbon, just like diamonds. As we heat the crystals, we see that they start to turn from a solid into a liquid. At around 700 degrees Celsius, all of the crystals have melted and we're left with a transparent liquid. This means that the crystals we grew are indeed diamonds. Diamonds are one of the hardest minerals on Earth, and they are also one of the most beautiful. They are formed under immense pressure and temperature deep within the Earth, and they have been prized by humans for their beauty and durability for thousands of years. Diamonds are made of pure carbon atoms that are arranged in a specific crystal structure. This structure is what gives diamonds their hardness and their brilliance. Diamonds require a lot of energy to form, and that S, exactly what we doing today, S? Experiment! We gone, Use a machine called a high-pressure reactor to simulate the extreme pressures found deep within the Earth. With this machine, we can generate pressures of up to 200 kilobars, which is equivalent to the pressures found at a depth of 60 miles below the Earth's surface. Now, to make our diamond, we're going to use a special mixture that contains all the carbon atoms we need. We gone, Load the mixture into a special container that can withstand the extreme pressures we about to generate. Once the container is loaded, we're gonna close it and then place it into the high-pressure reactor. We gone. Start to pump the air out of the reactor and then backfill it with a small amount of an inert gas called argon. The argon gas helps to prevent any unwanted reactions from occurring while we're generating the high pressures. Now we're ready to generate our diamond. We're going to start pumping the pistons on the high-pressure reactor, and as we do, the pressure inside the reactor will start to increase. The pressure climbs higher and higher and higher until we reach our target pressure of 200 kilobars. At this pressure, the carbon atoms in our mixture will start to bond together and form a diamond crystal lattice. We gone. Hold the pressure for a few hours to make sure that the diamond has enough time to grow. Once the pressure is released, we can open the reactor and take out our diamond. It's so exciting to see what we've made. Under normal conditions, it would be impossible for us to grow such a large diamond. But with the help of our high-pressure reactor, we were able to simulate the extreme conditions found deep within the Earth and create a real-life diamond right here in our lab. Well, that's the end of today's science experiment. I hope you enjoyed watching it as much as I enjoyed making it. If you did enjoy it, make sure to leave a thumbs up, subscribe, and hit the notification bell. Also, if you want to watch more experiments like this, you can check out my channel. I have hundreds of fun science videos that I know you will enjoy. Anyways, thanks for watching, and I'll see you guys next time.